So let us look at distinctions between heat and work before we go on to some more problems. So if we have, for example, some kind of a system of this kind, and I have, let us say, a heating coil. Let us say this system is insulated from the outside. That is a heating coil which is connected to a battery. Now the question is, what kind of interaction does this have? The mass is constant because it is a system, it is closed, mass is constant. There is electrical power being sent in through this coil. So is there heat transfer or is there work done in this case? So that is something which we can look at. So for example, let us say that this voltage is say 12 volts. Let us say the current is 10 amperes and this goes on for a time of say 1 minute, which is 60 seconds. So how much is the heat interaction? How much is the work interaction? Can we find out, and how much is the change in internal energy? There is no change in potential energy of the system is fixed, it is not moving, there is no change in kinetic energy. Can we find out these? So whether we have heat or work interaction depends on our choice of system. So if, for example, I choose a system of this kind, so let us say these dashed lines represent my system. So the question is, what crosses my system boundary? So I have here in this system, I have this heating coil as part of my system. The system boundary is here for the heating coil. So at this point, what crosses the boundary of the heating coil? So over here I have current which is flowing into the heating coil and going out. So I have this voltage which is pushing a current through the heating coil, which is doing work. We have discussed earlier that that kind of work would be given as the voltage into the current into the time. So in this case, because of my choice of system, I have work which is being done on this system. So the work interaction for the system is negative, and the value of this would be minus 12 into 10 into 60. So I have about minus 7.2 kilowatt. 70, yeah, I think that is correct. Minus 7.2 kilowatt is what I have as the amount of work interaction. Sorry, kilojoules. We are looking, I have already multiplied by time. So this is in kilojoules. That is right. So I have the work interaction to be minus 7.2 kilojoule. What about the heat interaction? This whole thing is insulated. So as far as my system which is concerned, here my system is the air or gas inside this plus the heating coil. The heating coil becomes hot. Because it becomes hot, the air also becomes hot, but both the heating coil and the air are part of my system. We do not talk of any heat transfer between different parts of the system because they are internal to the system. Any heat transfer or work transfer has to happen across a boundary. Our boundary now is this dotted line. Across this, there is no heat transfer because the system is insulated. So of course our boundary is coinciding with essentially the system, but I have drawn it a little inside so that it is visible. So there is no heat transfer across it because all of this is insulated. Therefore in this case our heat transfer is 0. And the change in internal energy I can get from the first law as the heat transferred minus work done. So that is 0 minus 7.2, which is essentially 7.2 kilojoules. So what this tells me is that the internal energy of my system increases because there is work being done on this system. There is no heat transfer, there is work done and the internal energy increases. This is what we would find out if we had a system which is taken in this fashion. Instead of taking the system like this, we could have also taken the system in a slightly different way. So, for example, I have the same configuration. What I can do is also take my system to include only the air. So, now my system is the air over here, and the air over here, but not the heating coil. So, the heating coil is external to my system. My system contains only the air. So, the values of current and voltage are the same, the mass is still constant. What I can now try to do is find out all of these. Now, in this system, if this is my boundary, what we see is there is current flowing through this coil, but the coil is no longer part of my system. So, any work done by the battery on the coil, because by its pushing current through the coil, is no longer work on my system, because the coil is not part of my system. Now, if I look at the work done for my system, the system is rigid, there are no moving boundaries, so there is no displacement work. There is nothing flowing through it, there is no flow work, there is no shaft, there is no electrical or mechanical work. So, the work interaction for my system now is essentially 0. How about heat transfer? I do not have heat transfer through these walls because they are insulated, but I have my system containing only the air, and there is this coil over here which is in contact with the air. This coil is hot because battery is doing work on the coil, but the coil is not part of my system, so that work is not important to me. But because the battery is doing work on the coil is hot, and because the coil is hot, it is giving heat. There is transfer of heat from the coil to the air, and that is heat transferred, which is there in my system. So, the question is, how much is that heat transferred? So, assuming that everything is in steady state, the amount of heat transferred can be given as, so if I now consider only the coil, so the coil, for the coil, there is work being done on the coil, and there is heat being given out by the coil. So, the work interaction for the coil, I can get it as minus of V into I into T, assuming that everything is in steady state, and this value is the same as what we had before, minus 7.2 kilojoule. If I was to write the first law for this coil as a system, the coil is having work done on it. If things are in steady state, then the properties do not change. So, I will assume for the moment that the temperature of this coil, it is already been at some high temperature and the temperature is not changing, then delta U would be 0 for this coil. And for this coil, if I write the first law, so this is 0 if the temperature of the coil does not change. So, what I am assuming is that the coil has been on for a while. I look at it now, the temperature is say 100 degrees centigrade and it is transferring heat. After 1 minute or 60 seconds, I once again look at it, the temperature is still 100 degrees, but it has transferred some amount of heat. So, now what I see is del U would be 0 and Q would be equal to W. So, for this coil, the heat transfer is minus 7.2 kilowatt, which shows that heat is going out of the coil. Now, for the system which contains the air, heat is entering the system. The amount of heat entering the system is the same heat which has been going out of the coil. So, this is given as V into I into T, or essentially this value, which is essentially 7.2 kilowatt. So, I have heat entering my system or containing only air, which is positive. Work interaction is 0 because there is no work here, and del U is 1 Q2 minus 1 W2. This is 0, this is 7.2, which is comes out to be 7.2 kilowatt. So what we see is that depending on how we define our system, we can either have heat interaction or work interaction, and the other can change. So here I have 0 heat interaction and I have work interaction. Over here I have heat interaction but 0 work interaction. The change in energy is essentially the same in both the cases, but depending on how I define my system, these other values can change. So it is very important to define the system correctly. Both of the definitions are fine, but we need to make sure that we write the formula consistent with whatever is our definition of the system. So if I write the system is this, then what I should keep in mind is there is no heat interaction. If I have the system like this, what I should keep in mind is there is no work interaction, there is only heat interaction. So this is a finer point which we need to keep in mind when we define the system. We are okay with doing it either way, but I should not draw the system like how it is in the bottom here and then mark the work as a non-zero value. That would be wrong. So this is something to keep in mind.